Hello, my dear students. Welcome back to the lecture. So the next drawing that we need to refer is the first floor reinforcement layout. Okay, that is first floor reinforcement layout. So this is a PDF what I have. I'll explain you with the help of AutoCAD drawing because PDF it is little difficult to understand. So I given this AutoCAD file. You can make use of it. Okay. So this is how the reinforcement details is given. The same thing is written here. Actually, we do it in the AutoCAD first. Later, it will be converted in the form of a PDF so that the site engineer can make use of it. Got it? Yeah. So it's written first floor reinforcement layout. Got it? So now we'll start like this. See, before I start this lecture, one thing I'll tell you, whatever I explain it here, if you're able to understand, it's well and good. If you don't understand, then also it's well and good. Because reinforcement details will take you some time to understand. Footing it was easy, column was easy, beam was easy. But whereas slab is little not difficult, it will take some time. So in this video, if you're not able to understand, you don't have to worry. Try to watch it once again. In spite of doing that also, if you're not able to understand, no issues. Because in future, we are taking more than 15 to 20 structural drawings. So by the end of this course, you will be in a position to understand all the drawings. But for the slab, initially it is little tough because there are a lot of reinforcement which comes. And there are few reinforcement which is given in the slab, which they don't mention it in the drawing, but practically we need to provide it. So that is the reason. And it's not like one single bar. There are 4 to 5 bar which will come in the slab. So initially you may find it bit difficult that you may not be able to not be in a position to understand it, but that is totally all right. Good. Chalo. So we'll start with that. So these are the different panels that is given. This is panel number 1. This is second slab. Okay. Then we had a cutout here. So there is no slab. Then you can see we had a lift coming here. So again, there is no slab coming here. So this was your attached toilet. You remember the plan, right? This was your master bedroom. And this was your foyer area. And this was your dining area. So you had a cutout here, open to sky. So there is no slab. And this was your corridor portion, not the corridor, yeah, the passage portion, right? And so this is how it is done. So first what I'll do, I'll take a simple this thing, slab now. Just concentrate only on this slab and all other slab you shouldn't see. Just concentrate on only one slab. So I'll close all other things. This is not required. Don't see all these things. Only one slab you concentrate, that is sufficient. Got it? Yeah, enough. So this is one slab what I have. So this is one slab what I have. Got it? Yeah. So how they have given the reinforcement? See, they have written something 2 feet 6 inch. Then they have written 5 feet, 4 feet and all. So first what I'll do, first to understand the concept. Near the support, you need to provide top steel. At the center portion, you should provide the bottom steel. Simple concept. The same thing you can see it here. What these people have done, they brought the top bar. You can see this is my top bar. He has given a crank and then he has taken it to the bottom. But one question may come in your mind, sir, previously you explained us like it will come like this, it will get a crank, it will go to the bottom, and again it will get crank, and again it will come to the top. Along with that, I also told you in slab we have 3 to different types of bar that we can provide. This is one type of bar. This is another type of bar. So this is called as alternate bent up. So alternate bent up in the sense, okay, alternate bent up in the sense. Let me erase all these things. Yeah, not required. No. So alternate bent up in the sense, what we do, we'll bring a bar, we'll crank it here, crank, and this will be going straight up to here. Now on the other side, I'll start one more bar. From here, I'll bring one more bar. This bar, it will be top, provided in this way. I'll give a crank, and now it will go straight. You're getting my point? This is another way of providing. The earlier way, the way we were providing was give a crank, bring it down, go straight. This is crank, take it to the top. Next bar was going straight. But here what is happening, we'll provide this crank here. You'll provide a top here. It will be given a crank. It will go into the bottom. Again, from here, from the top, it will start. It will come down and it will go in this direction. Got it? So in this way, all the part from here to here, everywhere, the same reinforcement will be provided. Understood? This much is understood. That is sufficient. Now, what is the diameter of the bar? What is the spacing between these two bars? That we don't know. So that is mentioned here. So if I delete everything, just concentrate here. So it's showing here. This point and this point is showing T of 8. That means you need to provide 8 diameter bar at 5 inches center to center spacing. That means the distance between these two bar. The distance between these two bar is 5 inches. So 5 inches is how much? 125 mm center to center spacing. Understood? So one side we have finished. The shorter side bar we have finished. Now I'll go to the longer side. So this is my longer side. So for longer side, again, I'll close all these things, not required. It will be confusing. I'll remove all these things. Not required, not required, and not required. Okay, yeah. Now come to the longer direction. So longer direction also same thing. What you'll do, you'll start the bar from here. Okay, yeah. You'll start a bar from here. Okay, then this crank is given and it will be going to the bottom portion. Got it? And from the other side, what will happen? Exactly. From the other side, you'll start from the top. Your bar will come from the top. It will be given a crank and it will be taken to the bottom. So in this way, you are going to provide the reinforcement. Same thing, whatever you provided in the shorter span, the same thing you'll provide in the longer span. So it's a two-way slab. So both the side I'm providing a crank bar, right? Suppose if it was a one-way slab, then what would have happened? Suppose if it is a one-way slab, then simply I would have provided a distribution still like this. That's it. I would have provided a distribution still like this. There is no cranking and all. But it is a two-way slab. So that is the reason we need to provide crank in both the direction. Now, next question may come, sir, how did you know that this is two-way slab? So usually one is by looking into this particular shape, I can come to a conclusion that this is a two-way slab. One way of understanding. Second way of understanding, you look at the reinforcement that is given. So by looking at the reinforcement, he's providing crank here also, and he's providing crank here also. From both the sides, the crank is provided. So I know it is a two-way slab. Even then, if you're not able to understand, that is fine. In few of the drawing, they'll mention whether it's a one-way slab or two-way slab. So totally depends on the structural consultant, how he has given. I'll show you further drawings where they mention two-way, one-way and all. So based on that, easily you can identify it. Simple? Yeah. So now coming to the next question. What about this bar? This bar, what is the diameter of the bar you're supposed to use? Those things also we need to check, no? For that, again, they are going to mention it. So where they have mentioned it, I think here it's not visible. Yeah, it's mentioned here. See, this two bar is telling here. See here. You need to provide 8 diameter bar at 7 inches center to center. That means this bar, whatever you are providing, no, it should be made up of 8 mm, and the distance between the two bar has to be 7 inches center to center spacing. Understood? This much is clear. Good. Now, forget about other part. All these things is not required for you. Like now you may feel like, sir, see, there is one bar coming here. It has gone to the top. Why it is continuing here? So those things, no, it's not required now. As of now, just understand only this much part. Now, anyhow, I think you have understood that. I have made it even more easier by doing it like this. But anyhow, I'll explain this also. What I'll just copy this. Okay, give me a, and quickly I'll keep on placing. Okay, wait. I'll quickly place this so that we get an idea. Okay. Yeah. So what I've done now, I've created the same rebar here. Now, see, this is how it looks practically. Okay. Your bar will come from the top. It will get a crank. It will go like this. From here, it will start from the top. It will get a crank and it will go like this. Now you apply the same concept here. What is that concept? So first, let me try to draw one this thing line here. So this is that line, right? So here your bending moment was minimum from this beyond this point. Here also your bending moment was minimum beyond this point. So if I ask you to draw the bending moment diagram of this, can you do that? Let me do that for you. See, whatever concept we applied, no, that same thing we have to check here. So this was your bending moment. Up to here, it was positive bending moment. Up, not positive. Here, the bending moment was maximum. Here, it was minimum. So you can see in this portion, the spacing you see, this is how much. What was given in the drawing? It was given, I think, yeah, it was given 5 inches, right? So this is 5 inches, 5 inches, 5 inches, 5 inches, 5 inches, 5, 5, 5, 5, 5, 5, 5, 5. Good. Now, this portion and this portion, we know that in this portion, you'll be having a negative bending moment because of this beam and the slab junction, you'll get a negative bending moment. See, this is actually the bending moment diagram of your slab. But due to the beam, what will happen? You get a negative bending moment. That means now if I draw that here, you'll be having a negative bending moment. Then you'll get a positive bending moment. You get a negative bending moment. So this is negative. This is positive, that is sagging, and negative. Because of that, because of this negative, we need to provide the top steel. That is why what has happened, you can see the top steel is started from here, gave a crank, it has been taken here. Now next you will start the top steel from here, give a crank, it has been taken here. Again your top steel will start from here, given a crank and taken like this. You're able to understand now? So what has happened near the support, this support and this support, we have provided the top reinforcement, that is a crank bar is given to take care of this negative bending moment. Understood the concept? See, ultimately, whether you provide your bar like this, like how we used to provide a crank bar, gave like this, we had brought it like this, then we gave crank and brought this. And then next what we were doing, we are providing a straight bar. Then again, crank. So end of the day, your analysis, end of the day, the bending moment diagram for both of the reinforcement remains the same. Here also you see this spacing is 5 inches, 5 inches, 5 inches. So here the top reinforcement is starting here. Here there is no top reinforcement. Here again there is a top reinforcement. This distance is almost double. Same thing you can see. You have a top reinforcement here. Next bar you don't have top reinforcement. Next again you have top reinforcement. So this spacing is also double. So either you provide a bar in this way or you provide the bar in this way. The way the slab behavior remains the same. Got it? So you shouldn't get confused like why they have given a different drawing here. And earlier when I explained you why it is different, concept should be understood. Got it? Finish. So I hope with this I was able to make you people understand how the slab reinforcement has to be understood and you got an idea. Now let me give you a small idea here, but I'll not explain this part. Okay. So, but the next question is that why this bar is continue? Why they are continuing this bar? So right now we were discussing for only one panel. Practically there won't be one slab in your building. You'll be having more than 10, 12 slabs. In this particular building, you see, we have one slab, two slabs. Then this is my third slab, fourth, fifth. Then this is my sixth slab. Total 7 slabs are there. So when there are multiple slabs, what we do, we try to continue the reinforcement. So that means usually now what will happen, I'll show you the bending moment diagram for this particular slab. So you'll be having a negative bending moment. Then you'll be, I'll go with a darker one. Yeah. So this is negative bending moment. You'll be having a positive, and here you'll be having a negative bending moment because it's a continuous support. This is a continuous. Continuous means for this particular beam, you have a slab here, you have a slab here. Because of that, what will happen? Your both the side, the slab will try to lift up. So you'll be having a negative bending moment. Maximum amount of negative bending moment will happen. And again, it will be a sagging bending moment, and slight negative bending moment will happen. And then if I try to draw a line for this, that is the center line, I'll try to draw something like this. Okay, something like this, I'll draw it. Got it now? So you'll be having a negative bending moment, you will be providing a top steel. So here your bottom steel will come. So here, since you have a negative bending moment, what we are doing, we are going to provide the continuous bar here. Then again, we'll be having a sagging bending moment here, so bottom reinforcement. And here we have a negative bending moment, so we are going to provide a crank here. Understood the concept? So that is why what we usually do, no? We'll provide this bar, we'll give a crank, and this a crank in the sense it will go to the top, no? And this top will continue. You can stop here also. Then if you start again, when you start for this particular slab, no, again you have to start from like this only, no? You have to start like this only. Rather than giving two different bar, why don't you continue the same bar? So what we do? We'll just continue this particular bar in this way. In this way. Of course, this bar will come and stop here. Then from other direction, the another bar will come. So here you see, next bar will start from here. We'll give a crank and it will be going like this. Up to here, it will be coming. Got it? So in this way, when you have a continuous slab, we are going to provide a reinforcement in this way. So again, if you have understood this concept, well and good. If you're not understood, then also it's not an issue. Because in further lectures, we'll try to understand all these things. Got it? Similarly, you see here, we started a bar from here, gave a crank, it has been stopped here. So next bar, I'm starting from here. I gave a crank. Now, since this is continuous slab, because I have a slab here, suppose there was no slab, then I would have stopped it here only. But since I have a slab here, anyhow, I need to, when I'm giving a reinforcement for this particular slab, I need to start like this, give like this, and go like this. Instead of giving two different bar, what I'll do, simple logic I'll apply. I'll say you provide a straight bar up to here. Simple. But anyhow, why it is at the top? Because we know there is a negative bending moment happening. So in this portion, I told you, in this portion, you'll be having a negative bending moment. So this negative bending moment means you need to provide top reinforcement. So that is why the bar will be taken at the top. Got an idea? Like how it actually looks. Got it? Yeah. After that, if you have understood the concept, try to apply that logic on this particular diagram, and now you'll be in a position to understand that. Got it? Yeah. Similarly, I think most of the things I've explained you. Other things are not required. That is fine for this particular video. Whatever explanation I have given, that is sufficient. Yeah. I'll give you another explanation here. So try to concentrate on this particular panel. So here you see the same thing. First, you tell me the bending moment diagram. First, let me see if you draw the bending moment diagram only, you will be able to understand. So again, you'll be having a negative bending moment. It will be a positive, then it will be a negative like this. Okay. Similarly, here it will be negative, then it will be positive, and again in this portion it will be negative. Why? See, wherever there is continuous, you will be having a negative. So this will be negative. We'll be having a positive. We'll be having a negative bending moment. This will be negative. Of course, middle span will be positive, and this will be negative. Able to understand, right? Fine. So with this logic, now you start with the reinforcement. So it's a negative bending moment. So bar will start from the top. I'll give a crank and I'll take it to this portion. Up to here, I'll take where they have taken. Yeah, he has taken the bar up to here. Okay, fine. Hey, why didn't he stop it here? Because it's a continuous slab, no? So if I stop it here, then again from here I need to provide this bar. So rather than doing that, what we did, we'll continuously take this bar. Finish. After that, next bar. Next, what he has done? Next, he has taken this straight bar. He has given a crank, and now it's a continuous slab, right? Here also have a slab. So it's taken it to the top. Got it? So in this way, the reinforcement is provided. Same thing here. Again, we'll have a negative bending moment. I'll provide a top bar. I'll give a crank, and I'll take it straight like this because it's a continuous support. No, I could have stopped it here also, but this much small portion I have. So I'll go like this. Finish. Next, what I'll do? Next, what they have done? Yeah. Next, he has started the bar from here. Started the bar from here. So it's a continuous support. So what you'll do, you'll give a crank and you'll take it to the top like this. Got it? So in this way, the reinforcement has to be provided. So just try to understand the concept, what I have told. And most of the things, I think I've covered it here. And that is sufficient. That is sufficient because here there is a cutout. You'll not be providing any reinforcement. Okay. So yeah, I think most of the things I've covered. That is sufficient. Yeah, that is sufficient. Okay. So I hope you have enjoyed this lecture up to here. If you have not understood this particular lecture completely, that is fine. Something you have understood, at least the bending moment concept you have understood. So with that understanding, when we go further in the lecture, we'll be in a position to understand all the drawing. So practice up to here, try to understand. Yeah, one more thing, one more assignment. Now try to note down what is the reinforcement that we are used. Okay, the reinforcement what we are used here is, you see here, we are providing a 8 diameter at 7 inches center to center spacing. And here also we are used 8 diameter at 5 inches center to center spacing. Always remember, when you have a two-way slab and all, the shorter side bar, whatever you are providing, no, that spacing will be lesser compared to your longer direction. So what I'm basically trying to tell, say if this is my slab, see all these things you need to note down so that you can take decisions on the site. So this is a slab what I have. So which is my shorter span? Of course, this is my shorter span. So this is my shorter span, isn't it? So these are the bar what I have provided. So what is mentioned here, you need to provide. Okay, leave it. You need to provide 8 diameter bar at 5 inches center to center spacing since it's a shorter span. This bar. This was my longer direction bar, this bar. And what was written? You need to provide 8 diameter bar at 7 inches center to center spacing. So what conclusion you can draw? What conclusion you can draw? So this is 8 diameter bar, shorter direction, I'll write shorter. This is your longer direction bar, but here also it's 8 diameter. Diameter remains the same. But look at the spacing. Here the spacing is 5 inches. Here the spacing is 7 inches. So always in the shorter direction, the bending will be more compared to your longer direction. That is the reason you require more steel in your shorter span. So more steel in the sense, more bending moment will come. So more steel is required. More steel can be provided by giving a lesser spacing. So here the spacing is 5 inches, but here 7 inches spacing is sufficient. So tomorrow, if you don't know, let us say you went to a site or you are looking into a drawing, you don't know in this drawing which one is a shorter span, which one is a longer span. So you don't have to look into this thing, length and the breadth of the this thing slab. Directly come and check the reinforcement. So wherever you find the reinforcement, bigger dimension of the reinforcement and lesser spacing, that will be a shorter span bar. Now again, 100% this will not work out. There may be few slab where both the direction will be providing a 8 bar and both the side you will be providing 5 inches, 5 inches. In that case, you cannot identify. But in few cases, what will happen is if you're not able to identify the length and breadth of your slab, no issues. Look into the reinforcement part. So wherever you get the greater diameter and lesser spacing, that is your shorter span. So here both the diameter are same, but in some cases we may get for a shorter span, they might have provided 10 diameter. I'll write 10 here. Let us say they are providing a 10 diameter. Okay. So shorter span, let us say he has provided a 10 diameter bar at 5 inches, and your longer span he has provided 8 diameter at 7 inches. Got it? So that also can happen. Again, requirement totally depends on the steel requirement. Yeah. So the assignment part was try to understand what is the reinforcement given. So we are providing a 8 diameter everywhere. Here it is 8 diameter. See here, here we are providing a 10 diameter bar. So usually one thing you remember, note it down. In the slab, 8 and 10 diameter are sufficient. I'll repeat it. In the slab, 8 and 10 diameter bar are sufficient. You don't have to provide 12 diameter bar. Even if you see, it's a G plus 3-story building. Now try to understand the concept. It's a G plus 3-story building. Imagine the amount of load coming. It will be a heavy structure, not too much heavy, but J plus 3 is a quite good structure which will be having good amount of load. But still, the slab reinforcement you check only 8 and 10 diameter of bar we are using. So always remember, 8 and 10 diameter bar at 150 center to center is sufficient for all the slab, and for all the maximum building, this is sufficient. Further, when we go with other drawings, I'll show you the comparison. Even if you're putting a G plus 10-story building, 8 diameter and 10 diameter at 150 center to center is sufficient for the slab. But for the beam and all, you will have to require bigger diameter of the bar. For the beam, we had seen 12 diameter, we had seen 16 diameter. Column, we had 16, we had seen 20 diameter. But for slab, 8 and 10 is sufficient. Even for the footing also, 10 and 12 is sufficient. Footing, we don't go with 8 mm, but 10 and 12 is sufficient. So all these things you need to note down. Got it? So if somebody asks you tomorrow, maybe you got a drawing. Let us say you got a drawing tomorrow, and it has come to you for a checking. And maybe that consultant has given here 16 diameter bar. He has given a 16 diameter bar, let us say. And it's a G plus 3-story building. Then you can tell 16 diameter is not actually required for a G plus 3 building because we already seen it. Then you can proof check that. Then you can try to ask him like on what calculation you have done all these things and all. So if you have some basic idea only, you can ask question to somebody else. No, that is the reason. Try to note down all these things. So this was 8, right? Initially, let me change it to 8. Yeah, finish. Got it? So try to note down all these dimensions and try to understand. We'll see you in the next lecture. Thank you.